Since the invention of the telegraph, telecommunications improved and expanded at a growing pace. Nowadays, with 5 and 6G, we are offered performances that would have been unimaginable just 20 years ago. These services are being brought even to isolated and impoverished areas. However, these advances need more and more energy to happen, but we cannot afford to exploit fossil fuels as freely as in the past. Plus, building expensive infrastructure for short or limited use is a waste of resources. An answer to these problems could be found in self-sustainable, drone-based telecommunication networks. These are portable systems that exploit rotary-wing drones to serve the ground users. The energy they need is provided by a mix of renewable energy and storage systems. At Painless, we believe that such solutions will become more and more common. So, we have developed DroneS, a design methodology that respects the technical requirements while minimizing the investment cost. Let's see a typical example. You need to harvest data from a set of IoT nodes deployed in a rural area, but you don't want to waste money. Our DroneS platform is the perfect drone-based solution for you. Give us the location of the nodes and the time difference of arrival, TDOA, of the network. We give you the configuration of the system. You deploy a UAV and it follows the optimized trajectory above the nodes. During the flight, each node is scheduled for data transmission depending on its proximity to the segment of the trajectory. The UAV continues harvesting data either until the end of the service period or until it runs out of energy. What happens if we have a service time greater than the active time of the UAV? The depleted UAV is sent for recharging and an idle UAV replaces it. Wait, how do we guarantee energy availability in a rural scenario? We use an energy harvesting system based on photovoltaic modules. What if there isn't enough solar irradiation to meet the load requirement? We use batteries to complement the PV modules. The batteries can supply the load when there is a deficit of energy from the PV units and get recharged when these generate excess energy. Let's have a look at how we propose to design a system like this. The first thing we need is the distribution of the ground users we should serve. Ground users can then be grouped into clusters, and a central point is found for each cluster. How can our drone visit each cluster center in the most efficient way possible? This problem is comparable to the easy-to-solve traveling salesman problem. The resulting path is divided into several segments, each short enough to assume the velocity within it to be constant, though unknown. The velocity and length of each segment are found using convex optimization, giving us a complete trajectory design. But how can this drone timetable be seen as a load profile by the energy system? Because of the periodic nature of the missions, we generalize the expression of each drone's state using a sinusoidal function, which is later translated into the logic domain. 1 for charging, 0 for not charging. We can then find the optimal number of PV panels and battery units by using a simple constraint search algorithm, which tries all the combinations until the boundaries are satisfied. Adopting this methodology can be hard if you're not already familiar with it. For this reason, we have developed an easy-to-use interface which lets you manipulate the parameters and variables in an intuitive way. Advanced settings are predefined and hidden by default, but can still be easily accessed. The main window is divided into 4 tabs, each dedicated to a different set of input data. Visit our website if you want to know more, or to use DroneS directly from your browser.